Now what I will do is I'll make you to get a real taste of what does it look like. Okay. So now we have something like this. If we have 3, okay, so this is same as writing as z equals to 3 plus 0i, right? So our y component is 0 and x component is 3. So in the number line itself, what will you see is that you can just represent like this. From here, a y component is 0, so x only is 3. So here it is 3. Okay. And if you see carefully, if I write like this, minus 3, then z equals to minus 3 plus 0i, which means that it is just this side, and it is minus 3, and this is origin. So if you see very carefully, what it says is that the value from here, the length of the vector here and the length of the vector here are equal, but only difference of sign. So if you see very carefully, this 3 and this 3, this negative 3 is just the reflection or the rotation of the 3 by the angle pi. Are you getting? This 3 is just negative 3, it has become negative 3. Why? Because it has moved from this end to this end of the number line by making angle pi, which is 180. Right? It is that it doesn't mean negative 3 is shorter than positive 3, but it is that it has just reflected or it is just rotated by the angle pi. So if you see this very carefully, we can just deduce from this formula how much we have rotated. Okay. So here, see here, z is z bar, z is z bar e raised to I pi, or you can write as z bar cosine theta plus I sine theta. See here. Now, what is our z bar? Z bar is x squared plus y squared whole root, right? So it is just, what is x? This is x and this is y. So x is 3 squared plus 0 squared, this one. So it is 3, right? Now let's find what is the angle. So we know that tangent theta is y over x, okay? Which implies theta equals to tangent inverse of y x. Okay, so if you see very carefully here, what is the value of y? Our value of y is 0 and value of x is 3. Now from this, what can we make it out is that we know that tangent theta equals to sine theta by cosine theta. Okay, so if you can see this, tangent theta, our tangent theta will be 0 if sine theta equals to 0 and cosine theta is not equal to 0. It is that our tangent theta will be 0 only if our y is 0 and x is not equal to 0. Okay. As well as you can see that if tangent theta will be infinity, right? If sine theta not equals to 0 and cosine theta equals to 0. Okay? Because if you divide any number by 0, it is undefined, but in terms of trigonometry, we treat this as infinity. So what does it mean is that here by number 3 means that tangent theta equals to 0 by 3, right? Which means our sine theta is 0. So this sine theta is 0 only if our theta belongs to n pi, where n equals to 0, 1, 2, 3. So if our theta is the integer multiple of pi, which is pi, 2 pi, 3 pi, always our sine theta, if you recollect our function, our sine theta is like this, right? So 0, pi, 2 pi, 3 pi like that. So every pi, our sine theta value is 0. So only if our sine theta value is 0. So see here, from this to this, our angle is from 0 to pi by 2, right? So which means that when we see this 0, which means our angle subtended is 0. So what does it mean? Angle subtended by 0 means from x, y like this, from x coordinates, we have not moved any angle, which means our number 3 lies here, right? So it shows that our number 3 is still on the number line. So it is compatible with this formula. Now let us see with negative 3. Okay? Negative 3 means that if we write in the Euler's formula, we know that our z, which is negative 3, can be only written as 3 times cosine pi plus I sine pi, right? Because our cosine pi is negative 1. So if you multiply with this, you will get negative 3, which means that our number negative 3 is not less or any less than 3, okay? But this 3 just rotated by the angle pi, because you can see that if you rotate by the angle pi, you will get negative 3. So which means that if you have just rotated by the angle pi, so it is just like that. Okay, now let us get to what does I mean. Okay, so you can see here that we can write like this, 3i. So in this form, you can write in rectangle coordinate as z equals to 0 plus 3i. Here, x equals to 0 and y component equals to 3, right? So if you see very carefully, if you write in Euler's formula, we have z equals z modulus cosine theta plus I sine theta, right? So to find theta, as I said, we have to find tangent theta by y by x. So theta equals tangent inverse of what? Y, what is y? 3 by 0, right? So if cosine is 0, which means that this will tend to infinity, right? So cosine 0, cosine theta equals to 0 means our cosine theta belongs to pi by 2 plus multiple of pi, and n equals to 0, 1, 2, 3. So if you see very carefully, if this is sine theta, then this is theta, then you can see that our cosine will do like this. This is pi by 2, like this, then negative 1 here, then 3 pi by 2, 0 again, then here plus 1 like this. So our cosine is 0 only if we have angle belonging to pi by 2 plus n pi, which means that from 0 to pi by 2, our satisfactory angle is pi by 2, which means that our theta is pi by 2 here. Okay, so by writing this, we can say that z equals to this modulus is just x squared plus y squared whole root, right? So you can say 0 plus 3 squared root means you can get 3, then cosine pi by 2 plus I sine pi by 2. So what does it mean? Cosine pi by 2, I have already said it's 0, and sine pi by 2 means just I, because sine pi by 2 equals to positive 1, right? So we get z equals to 3i, okay? Which means now we got that angle equals to pi by 2. So what does it mean is that in the complex polar plane or polar plane, see here, your angle, your complex number lies here, see, 3i. And this real and imaginary, you have just moved by the angle pi by 2. Correct? So what does it mean is that when you just multiply number with the imaginary number, you are just rotating the number to the angle by the angle pi by 2. This is the main fundamental reason. 3i means you have rotated, for example, from 3 here. If you rotate by the angle pi by 2, then it's same like just multiplying with the 3i. So what about multiplying another with I? Now we get 3i squared equals to negative 3, which means from here, your number is here right now, 3. If you multiply again with 1i, then you're rotating again by the angle pi by 2. And now you have reached to 3. Which means that every time, if you multiply any number with imaginary number, you are rotating from this horizontal axis by the angle pi by 2. Then if you again do this, again you are rotating the number from pi by 2 to another pi by 2 to get the negative number. So this is how a number works. So our basic line is that if we have some number 3, like some number, that it solely lies on the x positive axis. But if you multiply with negative 1 or make it negative 1, your number is not less than 3, okay, by magnitude, but you have just rotated by the angle pi. Likewise, if you multiply this number by I, you are just rotating from this pi theta equals to 0 to theta equals to pi, which is theta equals to pi by 2. Every time you multiply with this I, you are just rotating the number by the angle pi by 2. This is how you have to take in mind. And if you see carefully that last one, where does this complex number comes? So if you see, draw the phasor diagram, for example, like this. Okay. So here is origin. For example, if you have z equals to 3, then we all know that this z lies here. So this is complex number 3. This. And our angle is 0, right? Now, if you say z equals to 3i, then your complex number lies here. But you have rotated by the angle pi by 2 system. Okay? And if you say z equals to 3i, z equals to negative 3, then you have just flipped this number by the angle pi and you got it here. Negative 3. Okay. So if you see this diagram very carefully, here I have told that when z equals to 3, okay, so you have flipped by the angle 0 radian or 2 pi, and by 3i you have flipped by the angle pi by 2, and negative 3 means you have flipped by the angle 3 pi by 2, and 3 means you have rotated the number from this number line by angle pi. Okay, so you can see this if the angle is between 2 pi and 0, which is 360 degrees and 0 degrees. But what about flipping the angle or flipping a complex number z by the angle, for example, pi by 6? So by this angle, definite angles, you would get that your complex number, your number lies on the axis of the number line, where in any situation your x or y, one of them is 0, right? But when you want to flip the angle by the angle which is not equal to this, but between them, for example, as I have said, pi by 6, which is 30 degrees. This is where your this form z equals to x plus iy comes into picture. For example, if you want to flip this number by the angle pi by 6, which means that at this point, if you see very carefully, you see that my x is not equal to 0, y is not equal to 0, but it has both the term. You see this carefully, this is your x and this is your y. So at this point, if you flip by the angle which is not these angles but between them, then you get the complex number, which is your number z, which will have x plus iy component, or your number will have z equals to z modulus r theta, z modulus and theta. So it is like that. For example, if you do pi by 30, okay, which means that this number will be just pi by 30. So which means all numbers which are between these coordinates, coordinate 1, in the coordinate 1, in the coordinate 1, coordinate 2, coordinate 3, or coordinate 4. In the number which is between the coordinate 1, 2, 3, 4, any number which lies here, lies here, lies here, lies here, will have this complex form where x will be not equal to 0, y will be not equal to 0, but they will have the combination of that. But if the angle is this 0, pi by 2, 3 pi by 2, between the angle which it lies is the pi by 2 pi and 0, then your number will have definite values like that. So I hope you all would have understood, and I will see you in the next video, and thanks for watching. Bye.